Okay, well, imagine I played some song there. Okay, God bless. There's no words in it, so I could hum it. Okay, all right, well, let's pretend that song happened. Great entrance. Okay, I'll walk up, and that'll be a song. Yeah, all right. That was a great song by Van Halen. All right. If you haven't figured it out, I am a Linux user. So video and audio, neither one is working today. But it's extremely common. So, all right, this is me. My name is Todd Resudek. I'm a staff engineer at a company called Jackpocket. Anybody heard of Jackpocket? Yeah. Hey, look at Adam. That's good. He works there too. And I'm a Hex core team member, so yeah, I work on build tools, and that's my Twitter handle there. I don't have as many followers as Mickey, but you could follow me if you wanted to. All right, it's been a long time since I've seen you, friends. I just want to let you know I haven't forgotten you, and I'm really proud of all the things you've done. All right. So if anybody saw the title of this talk, some of you might recognize it, some of you don't, but it's taken from this verse of the Bible. I just didn't want to take credit if you thought it was like a really catchy title or something. So the thesis here is that different problems, I don't think this is controversial, but different problems can be solved better with different tools. And since most of our applications are already using SQL, I just want to show a class of problems that I think might be better solved in the database versus in the application layer. Somehow I got blank slides in there. All right, so let's go through the Wayback Machine. So Postgres, like this could be what you consider the beginning, like the genesis of the Postgres project. So it started as the Ingress project. It's called Ingress at UC Berkeley. And it's actually not used for what it's intended for. It turns out they applied for a grant and got funding for this geographic image service. And so that's why this was called Ingress. But I guess it sort of took a turn. So so they worked on that at UC Berkeley. In 1982, they started working on a proprietary version of Ingress. And in 1985, one of the original leads from the Ingress project started to work on a project he was calling Post-Ingress. So you kind of see how we're getting there. And then in 94, UC Berkeley officially ends their development of the Post-Ingress, which at that point was just being shortened to Postgres project, and they open source all the source code for it under the MIT license. So 94 is, we're starting to get closer. Later that year, two researchers added support for the SQL query language. So up until that point, it was using its own version of its own unique query language called InQL, I think. So this is 94 is really the genesis of the Postgres that we know now. And in 1996, they officially renamed it to PostgresQL. So if you talk to anybody that's been around or was at UC Berkeley and you say, yeah, I use Postgres, they might be like, no, you use PostgresQL. Postgres was this thing I worked on in grad school that used this other query language. So this 96 is when we officially get PostgresQL. And jumping ahead today, the Wikipedia page honestly just didn't have a whole lot between 96 and here. So I don't know what you expect from me. So today, PostgreSQL is the fourth most popular relational database system behind Oracle, MySQL, and MSSQL. And so some of us have probably used PostgreSQL for a few years, and every version or minor version, something new comes out. It's just constantly improving. All right. Is this obvious enough? Okay. All right. So there's some caveats to this. So I'm going to give some advice, And keep in mind, I'm an idiot. So it may or may not work for you. So first caveat, are you already using PostgreSQL? Okay, if you're, yeah, okay, we've got, I didn't, yeah, it wasn't a survey, sorry. So if you're currently working on a project that uses a document store or something, this doesn't apply to you because you'll have to add PostgreSQL. It's not really doing you any favors. It's probably causing you more harm. I mean, I would recommend moving to PostgreSQL, but this is not advice you can take home and like start putting PRs up on your project for. The second thing is like look at your load on your SQL database. So a lot of the applications that I've worked on, if you look at the CPUs, like the database CPU is constantly at 3 or 5%, right? And your application CPU is most likely much higher than that. If you were to have the inverse, moving logic out of your application and putting more burden on your PostgreSQL would not be recommended. So keep that in mind. I think that's an unusual situation, but you definitely wouldn't want it to put more work on your Postgres servers, I guess, if they're already taxed. All right, let's get into some examples. All right, so the theme of the talk is cars. If I would have played the song at the beginning, it would have kind of all tied together, so just keep that in mind. So complex constraints. So this is like, this is based on, all these are based on real world examples, but I've simplified them so as not to, reveal anything about what I do. So let's imagine we have this schema. So we have a car schema, and we say engine type, and then we have miles per gallon and kilowatt hours. So in a car, your engine type, let's say you have an internal combustion engine or an electric motor. So that would be like the values of engine type. And an electric motor doesn't really have MPG, and internal combustion engine doesn't really have kilowatt hours. So this is an example where you'd want a complex constraint. So you basically want to say, hey, so this is what your change set could look like a custom validator in there to say, hey, take a look at the change set and look at the engine type. And if the engine type is electric, we want to make sure that the MPG can be nil and the capacity is not nil. So that's validating. So essentially you want to say, hey, if this value is this, I want to make sure this column's nil and this column is definitely not nil. And so, this would be your validation that you could put in your change sets, which is, fine. But if we run it through the Postgres machine, the Transmogrifier, I don't know what this is, by the way. Does anybody know what that is? It's a PostSQL machine, PostgreSQL machine. So, okay, hopefully it's not like a Kitten Shredder or something. So, sorry, if we transmogrify that into, like, what would that change set look like in Postgres? We can create a migration like this, so, and put the check constraint directly into PostgreSQL. So, in this case, it's at that validation is happening at the database layer, and when you run I think I have a slide for this. So yeah, when you add a check constraint using ecto code, it's going to check this constraint that you've defined on the database with that last migration, and if it comes back, it'll throw this error. So with a check constraint function, you can give it a custom error if you want to, error message after that. And so what happens here is we've just taken logic from what was in the change set and moved it into the database layer. And so the advantage, if you will, well, first of all, it's less code to look at. Secondly, I look at this as sort of like a belt and suspenders approach to things. So if you've done web development, you probably have forms that use front-end validations, like JavaScript validations, to make sure, this is definitely not going to work, and you're going to get a back-end validation if you try to send this, so let's just stop it on the client side. But then you also have back-end validations in your change set to say, hey, that doesn't look like a number, or that, your name is required. And so front end is the belt, and back end is the suspenders, and like adding this to the database level as well is like an elastic waistband on top of that. So even if it were to get past your JavaScript validation and get past your backend validation, it will never go in your database. If somebody pulls up tunnels to your database and tries to enter data manually, if somebody tries to import a SQL dump file, there's no way that an invalid data or invalid row can get into the database at this point. So I think of it as just like the next level of protection. And I mean, there are definitely times when people will be like, oh, I'm going to just put this in on the console or whatever, and they won't go around, they'll go around your change set, for instance. And so this is like a good way of adding that extra level of protection. All right, and the next example problem would be case sensitivity. So, and SpongeBob knows letter case matters, right? Like, this means something a lot different than if it was in a different case, I think. And so Postgres has a solution for that. It's called Scitext. But if you were going to do this in your application code, you might have something like this. So let's say you're going to put a car in there and you want to get the VIN number from the user, but some users make capital letters and some users make lowercase letters, and you just want to normalize the data so that when you're searching for it, you're going to be able to find the right match. And so you might have this function in your change set that says, okay, well, when I get a VIN string, just downcase it before you put it into the database. Now, with Postgres, sorry, the Kitten Shredder again. You want to see it again? Okay. All right. So in Postgres, there's an extension available called Scitex. Many of you probably have already used it. So if you just modify the type of that column, the VIN column, to Scitex, essentially what it's going to do is anytime you query it, it's going to do a drop case, a down case on both sides of the query automatically. So the data that's in the row looks like however the user input it, but anytime you're querying it, it essentially normalizes the case for you. And so that's like a pretty easy solution. If you do this, you don't need to put anything in the change set at all. And so if you look at this was the example of what it looked like before, and after you just can get rid of that function completely. Another one is adjacency. So I think the most common example of this is like a leaderboard for something. So if you're making like a game and you want to show the user's position on the leaderboard, but you don't want to say you're in 69th position, nice. You want to show who's in 67th and 68th and 70th and 71st as well, right? So you might have to do something like this. So in this case, for cars, let's say you're looking for a car by price. So you say, well, I want to show the user the car that is that price, but I also want to show them the car that's a little bit less and the car that's a little bit more. And so, in this example, you're running 3 queries. One that says, get me, order them descending by price and get me the 2 before it, and order them ascending by price and give me the 2 that's after that, and then give me the exact match. And then, you can build that list that way. But if you think about it, the way Postgres indexes work is kind of like, if you look at this car lot, if you were to index on price, essentially Postgres is organizing that data in this way already. So it'd be analogous to saying oh, that, green car in the middle is at the, let's say, $11,000 price point that I entered. But the gray car next to it is $10,900, and the dark car after it is $11,100. So Postgres already keeps them in an order for you. And so if you were to just use these window functions that are already built into Postgres, the lag and the lead function, what that is going to do is say hey, I want to get the price that's 5,000, but also select the lag and the lead on that. So it's just saying the window function is saying find that row, but then just expand your window a little bit and grab me the ones that are next to it as well. And so if the top there with the with base, that's actually a common table expression. I don't know how many people have used them before, but it's essentially a good way of doing recursion in SQL. So yeah, if you were to just write this query here instead, you just do one query. It uses the indexes. It's extremely efficient, extremely fast, and because Postgres is natively organizing things that way anyway. All right, the next one is string searches. And specifically fuzzy matching. You like the picture? Okay. No, oh, sorry, no, these cats weren't shredded. Nobody take a picture of this, okay? It's an NFT. All right. I'm glad you like it. It cost me $3,700. All right, what was I doing? Okay, so fuzzy string searching. So users are going on your car site. They're like, yeah, I want a Civic. You know, I got lots of money now. I'm going to buy a Civic. And but I don't know how to spell Civic. You know, so I type in CIVIC and search for that term. So you can't just use like an I like or a like statement in Postgres because it doesn't account for misspellings. So if you were to, you know, drop the K off, you know, it would help you with that, assuming you put the wildcards in the right place. So in this case, okay, we're saying, yeah, this guy wants a Civic or this lady wants a Civic, but apparently doesn't know how to spell it. And so in the application code, we could actually look for close matches using Elixir's string module. There's a Yarrow distance. Anybody? I don't know who that guy, who the person Yarrow is that it's named for, but if he's or she is here, sorry if I'm mispronouncing your name. So you could calculate the Yarrow distance of a string natively in Elixir, and then find all the but first you'd have to find all the cars, and then you'd have to calculate all the makes and models of the cars, those strings, and calculate their distances, and then you could go down here and say, okay, sort this by the ones that are the closest match and the furthest match. Just for you. I like cats, by the way. I have a cat named Taco. It was an accident. I was like, we were on the way to the shelter, and I was like, crap, I got to find a name for this cat. Because her original name was Celine, which I don't know if you like Celine Dion, or don't admit it if you do, but I was like, your name's not Celine. And then I was thinking, well, what do I like? I like tacos, so she'll be Taco. Okay. Okay, so we ran it through the Transmogrifier, and so this is the query that you could use. So instead of all that application code, pulling down, doing a MapReduce, counting the distances, and then displaying the closest matches, there's a very similar to Yarrow distance function that's built into Postgres called Levenstein that'll calculate the Levenstein distance of a string. And so you could use a fragment like this, you know, so this is all ecto code essentially. The fragment function is kind of the cheat code to drop into SQL and find the lowest Levenstein distance either on the model or the make. So they could search for Honda, they could search for Civic, and it'll search for both and find you the match that's the closest distance. So Levenstein distance is, just like Yarrow distance, is measured between 0.0 and 1, and the lower the number, the least distance it is. And so you can see this is like a bit less code. It's actually going to be a lot more efficient. There's a slight difference between Levenstein calculations and Yarrow distance calculations, just in that Levenstein is very particular about the position of the string. So like Civic with the K at the end would be a close match in Levenstein. In Yarrow, you could actually like transpose two letters. So if you were to put CIV, CI instead of IC, the Yarrow calculation would technically think that that's a closer match because it looks for similar letters but that are in the wrong position. So it's probably not going to affect you, but just keep it in mind, I guess. All right, the kind of the next level of fuzzy matching searching are trigrams or n-grams, I guess. So anybody use Elasticsearch for n-grams? Yeah, it's pretty popular. But so just for an example, if you haven't used n-grams before, let's say you have this list of strings and you want to make, in this case, they're trigrams, tri meaning 3, so it's sections of 3. So this is how trigrams are built. So basically you give a string to a trigram index and it turns it into a list or a vector of every chunk of 3 letters that exists in the string. And so you're essentially matching on any one of those. And so if you wanted to do trigrams natively in application code, you could calculate the trigram distance like this. And so let's say we've got a list of models up there, all starting with E, and then we could make the trigrams of those and then essentially like then we could search the list through Elixir. And so that long list is actually becomes these vectors in the application code that you're searching. But let's say you're a baller, right? Baller? All right. And you want to buy one of these. Anybody? Nobody knows what this is, right? This is a 1979 Cadillac Elegante. Okay, so this is ballers only stuff right here. So let's say you want to buy a Cadillac Elegante. Incidentally, this thing had like a 350 cubic inch engine that managed 170 horsepower. And I'm sure it weighs like 8,000 pounds. Okay, so you just ran into a bunch of money. It's baller time. You're going to treat yourself. Cadillac Elegante. Crap, how do you spell Elegante, right? So you're typing in searches, and so that's where the trigram comes in handy. Okay, hey, it's nouveau riche. You know, you didn't get rich because you're smart. But you have good taste in cars. Okay, so what we can do, instead of all that application code, we can just use this extension, this trigram extension, PGTRGM extension in Postgres. It'll automatically set up trigram indexes for you. There's two different ways of building those indexes. One's using the gin and one's using gist. This is kind of in-depth, but essentially like a gist index is going to be faster, but it's lossy. So essentially what happens with gist indexes is they can be built really fast, but they cause a lot of false positives, and so it ends up actually executing another query on top of that just to validate that it wasn't a false positive. Gin indexes are about 3 times slower, but they're not lossy, so you don't have that additional query on top of it. And again, this is just informative. You might be like, why is this trigram so slow? And your particular use case might allow you to use a gist index just fine. So for instance, if you were to, since these indexes take 3 times longer to build, you might be getting new data in all the time. And so rebuilding those indexes might actually slow you down more than having to do that additional query with all the false positives. So a gin index would be really good for data that's more static. So if you look at, like our example is car models, manufacturers don't come up with new models every year. And so like it's reasonable to think like it might be 12 months before I have to even rebuild this index at all. So a gin index is a good way to do it. Is a good way to do that. So and yeah, this kind of reiterates what I said. So if gin indexes are slower, but lookups are faster. Gist indexes are the opposite. And so once you've built the trigram indexes, this is how you query them. Now I've never seen this operator in any other language. Does anybody use any weird languages? Mark? No? Okay. All right, so this, 5-character operator is actually the distance operator for the PG trigram extension. And so this is, like the Levenstein, is going to give you a 0 to 1 match or number on that. There's, the opposite operator, which is like the closeness, and then there are also Boolean operators. So you could say, give it a threshold and use the Boolean operator and just say, like, give me the matches that are, within these boundaries. So that's pretty cool. And so if we ran our list through and we search for Elegante in there, like essentially this is the output of that. This is the distance from Elegante of all the known models that we have. All right, next level. Bloom filters. So does anybody know about Bloom filters? All right, we got some machine learning people here probably. Yeah, okay. So a Bloom filter is a space-efficient, probabilistic data structure conceived by Burton Howard Bloom to test whether an element is a member of a set. And so the language is actually pretty important. It will always be able to, it will definitively tell you that it is not a member of a set, or it could be a member of the set. And so I don't have my speaker's notes because Linux, so I'm going off of memory on this. So let's see how this goes. So essentially you tell it, I want to set up an index of n length. So n should be proportional to the amount of data that you want to store in the set. I want to build X number of indices on that. So the indices are hashing functions that you run through, and they spit out a value. So in this case, I'm using 3 hashing functions. And so when you run your value through the hashing functions, each one spits out a value. And in this example, let's say it spit out 1, 2, and 8. So it flips the bits. Sorry, was somebody? What? Okay. Okay, I'll ignore Mickey. Okay, 1, 2, and 8. So it flips those bits in this data efficient, space efficient set and says, okay, that value is there. And then the next one you run through, let's say those hashing functions result in 0, 2, 7. And so it flips 0 and it flips 7. 2 was already flipped. And so this is kind of where you get that that unsureness that it might say, oh yeah, all 3 of these bits have been flipped, so I think it's in the set. It might actually have just been overlap, essentially. So that's why you have to be, you really have to tune the size of the set based on the size of, or the amount of data that's in there, or yeah, essentially. There's a really big formula that I don't know how to make a lot of the symbols on my keyboard, so I didn't put it in here, but there's actually like an algorithm to determine, based on the order of magnitude of the set, like this is probably how big your index should be. And so yeah, just keep that in mind. It's always going to tell you accurately that it's not in the set, but sometimes it'll tell you that it is in the set when it's not. And so there's an extension called Bloom that exists for Postgres that will essentially manage this data structure for you. So you can create the extension Bloom and tell it the indexes. The length there is, the length of the vector that you're using to store those bits, and then the columns are mapped directly to the hashing functions and how much space that each hashing function will take. And so, oh, sorry, I'm hitting the wrong button. Okay, so that's a Bloom filter. The next level is a ribbon filter. Now, has anybody used a ribbon filter or heard of a ribbon filter? Okay, none of you work at Facebook. That's good. Okay. All right, so a ribbon filter is the even more space-efficient version of a Bloom filter. It was, I believe, created inside of Facebook. There's like one white paper on it that says, essentially, this is like a Bloom filter, but even more space-efficient, and that's like the extent of the documentation. So there's no support really for it yet. But I do want you to know about it because probably in like 2 years, there'll be like a ribbon extension for Postgres, and then forget all what I said about the Bloom extension and just scrap that and use ribbon instead. All right, we've come to the epic conclusion. And so this is the way I look at problems. First thing I do is I assume PostgreSQL can do this until I've absolutely proven otherwise. Almost every time, I find some native function in Postgres that can do this and probably do it better than I could do in application code. Consider the trade-offs. Okay, so this is a big one. So there's a specific reason why I didn't put any triggers in this example. Triggers, everybody familiar with triggers? Okay. Yeah, so I mean, triggers are great. They're very powerful. It's essentially like, if you come from the Rails world, like a callback method, which is like, why the hell did that happen? And oh, there's a callback method in some weird place that does this automagically. Triggers are kind of like that, but in the database, saying, oh, hey, if this event happens, go ahead and do all these other things. Extremely opaque. If you're the only person that's managing the project, use triggers. You'll know where they are. But no one else will ever know. And future you also might not know. So consider the trade-offs. If you are going to move application logic into the database, it's fine. Put comments in the place where you think somebody would go to look for that logic. So if there's a schema that's doing something in the database, go in the schema file, write a comment, write documentation that says, like, this is what's happening, and it's happening inside the database using this extension. Or link to the migration file that's in it. So that the next person or future you will come along and be able to figure that out, because putting things in the database is not the first logical conclusion you're going to draw for that. And it never hurts to use this belts and suspenders and elastic waistband approach. So even if you're doing it well in application logic, it never hurts to also validate things or put protection in at the database layer, just to, like I said, your data science team gets in there, Fs things up, or somebody, cowboy codes and messes things up in the database. This gives you an extra level of security on that. All right. I want to just thank my employer, Jackpocket, for supporting me in doing this, and thank Jim and all the organizers of ElixirConf for letting me be here. And that's it. I think we have a little time for questions from Tim. Okay, I'll take questions and compliments. If you have any comments, let's leave them to yourself. Okay. Oh, Tim, do you have a question?
When you're doing an approach like this, where do you draw the boundary of testing, and how do you avoid testing like database code, but still make sure that your application logic is doing what it's supposed to do?
Yeah, so I think everything in here either went through the change set anyway. Well, I think everything did go through the change set that I showed. And so you should be able to test this logic by proxy of testing the change sets. So I think that is where that's where I would test it via that.
So you're leaving the test in the Elixir lab?
Yeah, I mean, effectively the interface to all this stuff is through the change set. So I think the tests probably belong in the change set test. This is the guy that co-wrote the Elixir testing book, and he gave me a thumbs up, so two thumbs up. So that's the most thumbs you can give, and so that's good. Anybody else have? Kate, did you have? Do I like SpongeBob? I think he's kind of funny. My kids like SpongeBob. I used to go with the My Little Pony theme on most of my talks, but the last time I did that, nobody had any idea what My Little Pony was, and so it fell pretty flat. So I went with SpongeBob and Cars.
So when you're working with Postgres, you come up to a new repo and you're trying to figure out how the database is set up. Like you're trying to help new developers learn where the stuff is. What UI, do you like to use a UI in Postgres? How do you figure out if you're trying to explore the schema and do all, what's your favorite tool?
For me, what tool do I use to find out, like, this new project, how is the database schema set up? Yeah, I use an application called Postbird, which is a UI for Postgres, essentially. And I think there's some popular ones for Mac and Windows as well. But yeah, that's how I look at the database. Yeah, I don't know. Like I said, I'm not that smart. There's probably a better way. All right. Yes, sir. I come from very modest means. My mom did buy a Cadillac Eldorado in 1991. It was a 1984 Cadillac Eldorado, and so I have driven that. I'm proud to say I drove it when I was 16. I had my license for I think like 8 days. Crashed the car. The good news is in 1984. They didn't have such a thing as crumple zones. So you should have seen the other car. So no, I'm not baller status yet. So yeah, I got to get into crypto or something. Maybe I can sell that NFT for like a lot. Anybody want to buy a cat NFT? Chad, you want to buy a cat NFT? Okay. I'm going to look up the current going rate for a 79 Elegante, and I'll let you know how much it is. Yordis.
Yeah, are you selling the cat machine thingy?
The cat machine is proprietary. I can't sell the cat shredder. Sorry, but I'm sorry.
Do you really know about this Elegante?
Elegante. I think it's Italian for elegant. We have an Italian here. Elegante. She verifies it. Oh, is it Spanish as well? Elegant, but it's got an accent, right? No? Okay. I think Cadillac put Elegante. I do know how to spell it. I was going to talk about unaccents, but I dropped that slide because I didn't think I was going to have time for it. But there's Yeah, okay. Ask me about it later if you're really interested in the unaccent function. Okay. All right, thanks everybody.